How's it going, guys? Yeah, today I'm just going to be going through this command line argument parser that I've just sort of finished up the first version of it this morning. The idea behind it is that you're able to pass values directly from the CLI into any function that accepts, maybe a float or an integer or a character array. And this should just make it a lot easier to reduce the amount of boilerplate that you're making up in each one of your functions, because all that should be handled by this command line argument parser. It's also got some other neat features which are specifically designed for Arduino, but I'll go through them in a second. First of all, this is the repo here. I'll put it down in the description down the bottom there, and I just wanted to show you how you actually could go about implementing it into one of your own projects. So you go to the repo, you click on source here. There's also a few examples that you could go to as well in that main directory, so there's an examples folder there. But yeah, if you go to this source directory here, click on, it's just a single header file, it's just called Arduino clap. You can come over here, copy the file. Now in your Arduino IDE, you could use any IDE, whatever you wanted. You do an Arduino clap.h, and you're just basically matching this file name here over here. If that's not correct, then the file won't load. So save that, paste the value in, save again, and so then we can go back to our original sketch here and just say include Arduino clap.h. We can recompile our sketch there, and down the bottom here it says it's all happy. Now what we want to do is set up an Arduino CLI instance. I'm going to call it CLI. Then we need to set up our serial communications. Serial.begin, just all this normal stuff. You could do 9600, but I'm going to do 115200. Then we need to again set up our instance here, actually and attach our serial object here to our CLI, because that's how it's going to all work. So we do new Arduino CLI, and then we pass in serial. And next up, we need to add an argument. So for that, we need a function. So up here, we can create a function called echo, and this is going to take in a const char pointer, which is going to be our message. And all this is going to do is just print out the message to the command line when it's received from the user. So a simple echo. CLI, now we got to add our argument. And it's going to take a const char pointer. So here, what we're doing in these brackets here is we're just matching up this value here with the value that echo expects. Then we need to provide the command line argument with the argument that we want to trigger the function on. So in our case, it's going to be echo, and then it's going to be followed by this colon here. And the idea is when we pass a colon, it means that the following arguments are going to be wrapped in quotations. So if we passed a value, let's say hello world, then because of this colon, the command after echo is expecting quotations. If you passed it something like this, what it's going to do is echo out hello, and then it's going to treat world as an argument, and it'll give an error because world doesn't exist. So for anything that's const char pointer, you put a colon after the end of it. Next up, we create a little help string, and I'll show you how that works in a second, but it'll just be echo user input. And then finally, we pass in our echo function. So here, this echo here is coming from this function here. And just to enter our CLI, we just say CLI enter. Now this is a blocking function so that it won't exit the CLI until the user types in exit into the actual command line. And when that occurs, then it'll actually come into this void loop. So if you had any code running in the void loop, then that code will actually be executed, or any subsequent code down here. not reached until the user types exit. So if we recompile that again, you'll see it compiled successfully. So now we want to push that and upload it to the Arduino. I've just got some little Uno here. So now we can open up our command line. So this is where we can type in commands. You could, I'm just using the serial monitor for this, but you could use any sort of command line thing, screen or Pi.io, platform IO. So if we wanted to echo the words hello world, we just type in our echo command. So this is our command here, and then we put in quotations the command that we want to echo. So for example, we see we entered hello world, and now we're getting hello world back. So if we wanted to hello Harvey, we can send that, and now it's saying hello to me. So that's pretty cool, but the real feature is the fact that it'll do automatic transformations of these values into the actual respective types. So here, let's say we had an echo int, and it's going to accept an integer, and that's going to be our value. And we just want a serial.print line value. And we can save that. And then we want to add this to our CLI, add argument. And we're just passing in int here, echo int. That's going to be our argument name, for example. Echo an integer, and then we'll finally just say echo underscore int. So we recompile that and then upload it to our board here. Just clear the output. So now what we have is two arguments. So we could type in here help, and this is going to give us information about the arguments that we can enter. So for example, in our options section here, we've got echo, which is our first argument here, and echo integer, which is our second argument. And then we've also got these helpers. I'll just go through them in a second, but one to note is just the exit command. So if you typed exit, it'll exit the CLI. So if we want to echo our int, and we want to pass in the value of 100, so we pass echo int, and that's passing back 100, but it's of type int. It's not of type const char or char array. So for example, one thing that could happen is if you entered a value that's too high for the actual range that int can go to, because int has a maximum value of around about 32,000. So for example, if you entered echo int 32,000, it'll pass back 32,000. But if you type in echo int 33,000, it'll pass back 0. So it has an automatic overflow, so it'll return back to 0 if the value cannot be accepted. If, for example, you wanted to actually accept values beyond 32,000, then you could use a 32-bit integer, and then down here we'd just type 32-bit int 32. We'll re-upload that back up to the board. And now we can type in echo int 33,000. We can send that to the board, and now you can see we get 33,000. So it'll automatically detect that and prevent you from stuffing up your cases, and just returning 0 is, I think, is sort of the safest case that you can do. These are all defined in these templates here. So if you, for example, here, this is where it's detecting whether or not you've exceeded some bounds. So if you wanted to return something else other than 0, then you could change it in here, obviously. The other thing that's pretty cool is, for example, actually we'll go through the inbuilt functions there. So I'll just clear this output. So if we want to echo, we'll just type in help again. And what that'll do is come up with our helpers again. And there's three special functions here: range, loop, and array. And the idea behind these is to provide like an easy way of setting some sort of value progressively over time just from the command line. So for example, if we want to echo our integer, but we want to do it for values between 0 and 10, and we want to do that every 500 milliseconds, what we could type in is echo int range 0 to 10, and we'll do it 500 milliseconds. So I'm just splitting up these by colons. So what you can see is it'll progressively do that same function over and over again from 0 to 10, and then once it finishes, it comes back into the command line. We've also got a loop here, so the syntax is the same. Echo int, we'll say the loop, we'll say from -10 to 10, and 500, we'll say 100 milliseconds between each one of them. The difference between the range and the loop is the loop will just continue forever and ever until you press reset in the Arduino. So now we're back into the CLI. Now if we go back to help again, there's one last one here, which is an array. This one's pretty neat because what you can pass in is echo int, I don't know why that stuff, oh no, it's just scrolled off. Echo int array, and now this time instead of passing our interval first, we pass it in, instead of passing the interval last, we pass it in first. So for example, we'll say 500 milliseconds, and then we can pass in an array of arbitrary values. So we can say -20, positive 180, 55, 82, 81 or 82. And so what that's going to do is go through each one of these values in the array here and send them over to our echo int function. So this could be any function. It could be controlling some sort of servo arm or anything like that. So that's pretty neat. Another thing you might want to do is actually pass a value where it doesn't accept some sort of value, it just triggers something. So for example, startup, and this accepts no value. And we'll just say it's powered up. So how can we add that to the CLI? We can do CLI add argument, and this time we don't even have to pass in a type, we just say start, we'll say startup, start the system, whatever the system may be, and that we'll just pass in startup here. We'll clear that throughout again. So it's just uploading here, it's done uploading. So we can just say startup, and we say send, and it says powered up. We could also do something like this, startup, and then we can say echo int 500. So what that's going to do is going to execute first our power up function here, and then it's going to pass our value to this echo int function. So that could be start the power to a motor, send a value to that motor, and then do something else, come back to the command line. Next up as well, what you can do is, for example, all these functions here, if you wanted to pass some non-static member, and by that I mean some sort of class instance, which is pretty common to do. Show an example of that. So if you did include servo.h, and this is for example, a servo motor, so it's controlling some sort of arm. We create our servo instance, and I'm just going to call it servo. And in that, what we could do is attach the servo to a particular pin. We'll say pin 9. And then how would we actually go about passing in a value to that servo? The function to pass a value to the servo is called servo.write. And here we'd pass in some value. But how would we actually go about passing that to this add CLI? Well, one way we could do it, or one way you probably think about doing it, which is not the correct way, is it's going to accept an integer, and you might want to say just servo write, and in this area we've got servo so we'll get rid of this here, So this is not going to compile. And what it's going to say is an invalid use of a non-static member function. And this is because the servo object here is just an instance of the servo class. So for example, we cannot call it in this way. What we can do is wrap off non-static member function in some sort of lambda, and this is just some sort of function that is static, and then we can pass that into our argument. So to do that, we would do auto, and we would do servo right, and this is equal to, this is a syntax of a lambda function, so we're passing in an integer, which is some value, and in here we want to serial.print. I'm just going to say servo value is equal to something, and serial print line value, so just v, and we could do servo write v. So that's coming from this function here. So now we can get rid of this and instead write our servo write lambda function here. And the same goes, we've got this int here, and we're passing in an int here. So now recompile that. I just got to put a colon at the end of this. I've just gone a bit off the screen. So now we have a fair few functions doing all different functionalities and converting between different types, all within the CLI. So now if we wanted to reference our servo write function, we just do servo write, and we'll pass in some value which is going to be 10. Servo write is not defined. Oh, I didn't upload it, I just compiled it. So it has that sort of built-in thing as well, so if something's not defined or something like that, it has that error handling, it'll pass back to you what the problem is. So just clear the output. Right, 10, and now it's saying its servo value is equal to 10, and that's all set there. So that's the way you could go about implementing the CLI in your project. I think in the future, what I really want to be able to do is pass in multiple arguments into this command line. So for example, if we had a int float and then like a const char, and then we could pass in all those values, that would be pretty cool. So that's something I'll probably work on in the future. But if there's other functionality that you'd like to see in there, especially regarding these tricky functions with the helpers, where you've got the help range loop and array, if you've got other things that are interesting there, please get in contact, put an issue in on GitHub, and we'll see what can be done about it, to add it, because I think it's a easy way to get things going, at least with all this sort of Arduino stuff. So thanks for watching, I'll see you guys next time.